All right, everybody, welcome to Earth Science. We're going to continue with seasons. This time, we're going to move into the angle of the sun's rays. Now, you should have done a video that I don't have. Oh, I do have up still. This guy right here, which I know is a little bit dry and boring, but it's the shortest one that really clearly demonstrated that idea. So here's what we get in New York. We get one season where the sun gets up to a pretty high angle. In that video, they did it like straight on. We're never going to have the sun directly overhead New York State. That's not a thing that happens, but it gets to be a pretty high angle. So I'll draw one like that, that if the sun's energy is coming down, it heats up a certain area. Then there's another season where it comes in at a much lower angle. And therefore, if you want to think of it this way, it's kind of like the same amount of energy. If I just say the amount of energy that exists in this much space, call it X, has to heat up this area, whereas the same amount of energy has to heat up a larger area. So this does not transfer the energy as efficiently, therefore, it's cooler. So let's write that. This is lower angle. Um, Therefore, energy is spread out. I'm going to learn to spell, which is what we have in our winter. Over here will be the opposite, which I'm sure you can do in your head already. Higher angle, energy concentrated, which is what we experience in summer. So, combining all of this now, we've been doing this for a little bit. This idea with summer having the northern hemisphere tilted towards the sun does a couple of things. It gives us longer days, and now we're saying that it gives the sun at a higher angle, which is better at heating the earth. Winter, we're leaning back, so we have shorter days, which gives us the sun at a lower angle, which is less efficient at heating the earth. So both of those together are things that make the earth cooler in winter and warmer in summer. And I should say our region, really, because it's not the whole earth. Remember that the South and North Pole experience opposite seasons. So what this all comes down to is a fancy term for sunlight, incoming solar radiation. What we did, we being science in general, not me, it comes down to insolation. This is a fancy pants term for sunlight. And they took incoming solar radiation and they made like a mashup word. They put them all together, insolation. Traditionally, students get confused with this because it kind of looks like insulation, which is like that pink stuff you put in your house to keep the heat in, right? That would have a U right here. This is a completely separate idea. Insolation, incoming solar radiation. So to sum up what we just did right there, as the sun gets further overhead, which is our summer, the sun's rays are more direct and the angle is higher. Therefore, it's going to be warmer. As the sun gets lower in our sky, which is our winter, sun's rays are less direct and the angle is lower, which is the things that lead to it being cooler in winter. Okay? So we've got to get to these tricky diagrams right here because this whole like tilt back and forth is going to lead to where does the sun hit directly overhead? Remember, every day, every moment, how much of the earth is lit up? It's half and half. So yeah, let's write that. Half the earth is lit, half the earth is dark, and it's kind of like as it spins through, we experience night and day. But what's going on? Are we tilted in so that we're more kind of in that light part, or are we tilted away so that we're more kind of in that dark part? And again, we are northern hemisphere people. Or is it those two times a year where everything kind of balances out? And to review, which hopefully we're getting done by now, our seasons happen because our Earth's axis is tilted at a number you're going to want to remember, which is 23.5 degrees north. I'm not sure what I meant here, so let's just skip that blank. So in this box, what is the name and date of this day? So this would be northern hemisphere tilted towards the sun. It is going to be June 21. which is the summer solstice. So here's the thing. Here's the new thing. We're going to have a new vocab term called the zenith. The zenith is the name for the point that's directly over the observer's head, which is like whoever we're talking about. So if we're talking about like me in space, the point directly over my head. If we're talking about somebody in Nebraska, it's the point directly over their head. The questions will kind of say, for a person in blah, 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 what would they see at the zenith? It's just for that person, what's ever directly overhead in the sky. And again, 0 days in New York will the sun ever be directly overhead. It's got to be in between these two lines that we're about to talk about right now. So, on, in fact, this is the definition of the solstice. On June 21st, on the summer solstice, it's the day where the sun is directly hitting at 23.5 degrees north, the Tropic of Cancer. Those are the direct rays. So it's going to be the most intense sunlight on that day at that spot that the planet gets that day. It's going to be a situation where if you were at solar noon, you would have no shadow. Yes, you would have one in the morning because the sun would rise, but when it comes up, it goes directly over your head, straight down on top of your head. Your shadow would only kind of be below you, and then the sun will go down and set in the west. All right. This happens at this latitude of 23.5 degrees north. Now, that number should sound familiar. I know we said it right there, but we also said it way up here. That is the tilt of our planet, which isn't a coincidence. If you're like, wow, that's weird, that's quite a coincidence. It's not. It's actually logical because if the planet were straight up and down and the sun were hitting right here, it'd be hitting at zero. If we tilt it forward by 23.5 degrees, the line that gets hit directly just comes up to 23.5 degrees. It's geometry. It might be a little confusing, but it's like not a coincidence. All that is the angle that we're tilted towards the sun. Therefore, that's the latitude that is now getting nailed directly by the sun. All right, again, where we live, north of that, we're up in the mid 40s. Never, ever, ever will the sun be overhead. Which latitude is the sun of the zenith this day? You want to just circle instead of writing? There it is right there. 23.5 degrees north, Tropic of Cancer. Ooh, two new special latitudes today are the Arctic Circle, which is 66.5 degrees north. I'll put the little degree symbol in with a pen here. Or the Antarctic Circle, which is 66.5 degrees south. What's going on up there? And we mentioned this with that paper thing we're doing in the hallway. If you're at the North Pole up around this time of year, as the planet spins through, it's only in the sun. So they would have 24 hours of daylight. Let's just mark that up here instead of at the bottom. 24-hour day. But, oops. What about our friends down here in the southern hemisphere? There's a movie called March of the Penguins. It's kind of neat. I suggest it. And they show this, that it's just dark. It's just night for like 6 months. 24 hours dark. What about us? We're right about here. So in orange, I'll draw, we've got to spin through all of that and then come back around. That's a long day. And then in purple, I'll do night and a short little night right here. Okay. All again, still leading. Like this is just more support of this stuff that we've done over and over and over again. That the summer solstice is the longest day. All right. This is getting a little long. I don't know if I want to rewrite all that stuff. That's just the opposite. But what's going on here? This would be, let's do a couple of things. This would be December 21, winter solstice. So direct overhead rays, everything just shifts. Now it's 23.5 degrees south that's getting directly hit by the rays. Far away from us. That's why it's cold up where we live. We're getting it at a lower angle. And again, only in between the tropics will be the areas where at some day through the year you can have sun directly overhead. What about us in the mid latitudes? Again, our daytime will only be about that. We go through that much and then come around to the other side where it's dark. And in purple, we've got this big, long, scary nights. All right, this is right before Christmas. Very long night for the planet to spin through and very short day for the planet to spin through. Santa Claus, 24 hours of dark up there at the North Pole. Penguins, now they have the 24 hours of light there at the South Pole during the southern hemisphere summer, the northern hemisphere is winter. All right, so it's directly overhead there. Sorry, I'll try to have this right. Last circles we talked about 24 hours of light, 24 hours of night. Finally, equinox is when everything kind of balances out. And I know I mentioned this in another video, but the axis here would be like tilted either into the paper or out of the paper. Half and half lit. This would be either of the two equinoxes, which are 3/21 or 9/23rd. Or if you said 21st, I'm fine with that. Equinox, where's the sun directly overhead? Equator. How much day and night does everybody get? No matter where you live. 12-hour day, 12-hour nights. If you do remember, that's a tiny bit of a fib that our science teachers tell, but really it's close enough that we're good. If you're Santa, half, half. If you're us, half, half. Equator, half, half, and so on. Everybody gets half lit, half dark. That's what the equinox is. And the sun is bombarding, is directly overhead, giving people no shadows at solar noon at the equator. So we'll throw those in right here. We talked about all those down below, but let's do it on this chart so that we only have one chart to do. Spring, let's do equinoxes are the easy one. Sun is at the zenith at the equator. Equator. Summer solstice, what we call our summer solstice, June 21st, is when the sun, it's got to be kind of closer to us because it's warm. So this is at 23.5 degrees north. We call the Tropic of Cancer. It is written there. I suppose I should write it in. Tropic of Cancer. This one, the sun's going to be a little further away from us. It's cold where we live. What we call winter solstice, what the southern hemisphere calls summer solstice. Tropic of Capricorn. 23 point, sorry folks, 23.5 degrees south. Sorry, trying to go too fast here. All right. So the good news is we're done with notes. The bad news is all of this stuff is fair game on a test. And I've said it before and I say it apologetically. I'm sorry that you have to go through all this. It's a lot to memorize. New York State, in their infinite wisdom, this is the thing they really make the most memorization laden. We really got to get all of that down. All of it can be fair game for a test, along with what the celestial spheres look like and everything else. Flashcards, popping this up, making a printout, rewriting it, whatever works for you. But don't just shut this video down and say, yeah, I'm good. I know that stuff. Unless you really feel like you could pull this back into your head at any time. These and these are the hardest. Dates, 3, 6, 9, 12. We have 12 months and 4 seasons. Divide them, they're 3 months apiece. March, June, September, December. Equinox, equal. And I think the daylight thing, summer is a long day, winter's a short day. I think that makes sense. These two are a little harder. So do your best. Thanks for sticking through all this. I know it's a long one. Good luck, folks.